Okay, today we're going to look at recognizing perfect squares. So a perfect square, we can use a diagram to have a little look at this one as well. Essentially, where we have a square and both sides, essentially, because they are a square, they are the same length. And a perfect square, we looked at a few of these in some of our other factorizing examples. A perfect square is when we have a bracket and it's expressed as the same bracket twice, essentially. So a plus b all squared. Quite a few of you earlier were writing your answers when you were factorizing perfect squares like that one in the middle. But just try and remember, as a lot of you wrote in your notes, that that should always be simplified to a plus b all squared. Okay. To help us recognize a perfect square, we are, just like difference of two squares, we are initially looking for two square terms. So those two square terms that we're looking for are going to be our a squared and our b squared. Okay. But to check that it is a perfect square, we need to check for 2ab in the middle. Okay. So we'll do that as we go through, and if we get 2ab in the middle, then we know we have a perfect square, and quite quickly we can just factorize it nicely. So some examples. Remember, that's always what we're looking for. So the first one, let's have a look. So we're looking for two square terms, just like with difference of two squares, but this time also 2ab in the middle. So we have our first square term at the start, x squared, and our second square term at the end, 16. So if we look at our general form at the top for this first one, a will be x and b will be 4. If a squared is x squared, a is x. If b squared from our general formula is 16, b is 4. So then we just need to check for that 2ab in the middle. So 2 times a times b. A times b is 4x, so 2ab is going to be 8x. And that is what we have in the middle. So therefore, this one is a perfect square. So then we can just straight away factorize x plus 4 all squared. Okay, you've seen ones like those before. Those ones hopefully aren't new to you, but reminding ourselves of the principles of a perfect square will allow you to apply that to some different ones that we're going to look at today as well. So, second example. In this one, we're looking for our two squares. A squared, is that a square? Yes, it is. So a would be p. B would be 10, because 100 is our square that we have here. Okay, and then 2ab, in this case, ab is 10p, so 2ab is going to be 20p. So then we check for 2ab in the middle. Do we have 2ab in the middle? No, we do not. So this one is not a perfect square. Hence, we would need to use a different method to try and factorize that one. Okay. If you're interested in looking at how to factorize that one, we can try and use the quadratic formula, which you'll look at a bit further later this year. But what you might actually notice is this is a bit of an aside, so don't panic if discriminant. The discriminant is something that we can use to test if something can be factorized. And the discriminant is part of the quadratic formula, b squared minus 4ac, and that's the bit that comes under the root in the quadratic formula. Okay. And if we calculate the discriminant for this question, b is negative 10, a is 1, and c is 100, we actually get a negative answer, okay, which means it has no real roots. So this one actually can't be factorized at all. Okay. And you'll do a lot more work on the discriminant in year 12 or later. We might have a little look at it later this year. Okay. This third one, a is 6x squared, b is 2x. Okay. And then 2ab, we can check that is correct, is our 24x cubed. Okay. So this one will factorize to 6x squared plus 2x. No. All squared. Okay. So quickly before it runs out of time, a few for you to have a go at there, please. They are a mixture, so look carefully. Difference of two squares and perfect square. And your answers